Okay, from our last 3 factoring problems, number 7 asks us to solve or to factor using dots and then solve. Dot stands for difference of two squares, but again, we first always check for an overall GCF. I am able to take out 25 from both of those terms. I'm left with 4x to the 4th minus 1. Again, I still have dots, so that's great. So I have 25 times, 2x squared plus 1 and 2x squared minus 1. I get 2x squared by thinking to myself, what do I have to take times itself in order to get 4x to the 4th? Or you can say, well, what's the square root? Square root of 4 would be 2, and the square root of x to the 4th would be x squared. Now, we won't be able to factor those any further. However, we are able still to set them both separately equal to 0. That's fine. 2x squared plus 1. As I set that equal to 0, I subtract 1 first from both sides. So I get 2x squared equals negative 1. Divide both sides by 2. X squared equals negative 1/2. When I square root both sides, I get imaginary solutions, which, fine, just recognize that. So x is going to be the plus or minus I square root 1/2, but we don't like having the square root of a fraction because, remember, that's really the square root of the numerator. Square root of 1 is 1 over the square root of our denominator. We don't like having radicals in our denominator. So we multiply top and bottom by radical 2, and then x will equal the plus or minus, I'm going to call it I radical 2 over 2, so I just threw that I up in my numerator. So there are 2 of my solutions, and then I set my second set of parentheses equal to 0. We're going to get slightly better, and by that I mean just not imaginary answers this time around. So 2x squared minus 1 equals 0. First thing we do is add 1 to both sides. Divide both sides by 2. X squared equals 1/2. So again, x would be the plus or minus square root of 1/2, which would be 1 over radical 2, right? Distribute the radical to the top and to the bottom. But we don't like radicals in our denominators, so I rationalize my denominator. X equals plus or minus root 2 over 2. Number 8, factor the quadratic-like polynomial using U substitution. Well, remember, we always first of all, look for an overall GCF. I don't have one. So we always let U be equal to x2, whatever power is in our middle term, after we've taken out our GCF if we have one. So we'll let U be x to the 9th. So now this polynomial looks a lot better. We have U squared minus 9U to the 1st plus 20. Oh, what 2 numbers multiply to give me 20 and add to give me 9? 4 and 5. My signs are the same. They are both subtraction. U minus 4, U minus 5. Lastly, I put U back inside my parentheses. Sometimes I'll be able to further factor from there. I can't this time because I have x squared minus 4 and x squared minus 5, x to the 9th. However, that doesn't always end up being the case. Sometimes we'll get dots from there, is more often than not what would happen, or even SOAP if we have difference of 2 cubes, but this time around we don't. X to the 9th minus 4, x to the 9th minus 5. Last factoring problem, factor and solve. 10x cubed plus 5x squared equals 30x. The first thing you need to do is get 0 on one side. So we subtract 30x from both sides. So 10x cubed plus 5x squared minus 30x. And then, equals 0. Okay. Look for an overall GCF. We can take out a 5 and an x. So I'm left with 2x squared plus x minus 6 equals 0. From there, I will have to divide inside. So I take 2 times 6 and I get 12. My 5x is a long out front. I need 2 numbers that multiply to give me 12 and subtract to give me 1. I'll be 4 and 3. My signs are different. My bigger number is positive x plus 4x minus 3. Divide and slide by my leading coefficient of what I'm factoring. So I don't want to use 10. I want to use my 2 because I'm only factoring this polynomial in parentheses. So divide and slide by 2. 4 over 2 I'm able to reduce. So I have 5x and then x plus 2. I can't reduce the 3/2, so I slide 2x minus 3 equals 0. Whenever you factored out a variable, you have x equals 0 for a solution. So don't forget about that guy. And then we set each set of parentheses equal to 0. So that first set of parentheses tells us x also equals negative 2. And lastly, I'm setting that last set of parentheses equal to 0, x equals positive 3 halves.